Hello, and welcome to the fifth Near Contracts Workgroup call. My name is Victor, and it's a pleasure seeing you all here today. Really excited for us to look at NEP 330 and make a decision about it. So this is our agenda for today. First, we'll look at the objective for the call. Next, we'll introduce everyone that's involved. Then we'll get into the main conversation of NEP 330. And after that, we'll open it up to Q&A and speak on next steps. So hey, feel free to introduce yourself in the comments and drop any questions you may have. And now let's take a look at the objective for today's call. So yes, we're here to publicly vote and arrive at a verdict for NEP 330. We're also here to celebrate the time and effort that everyone has invested into this NEP. There's 4 key roles in the NEP process. There's the author, who is the person that writes the proposal and presents it to the work group. There's the moderator, who facilitates this process, and there's a reviewer who reviews the technical feasibility of the proposal. There's also an approver as well. So very quickly, to visualize this process, you can see there's 3 phases: the draft, review, and the voting, and 2 possible outcomes: approved and rejected. All of the roles I mentioned help move the NEP through these phases and towards the outcome. Most of the activity happens asynchronously on the NEP itself on GitHub, but when we do get to a voting phase, the work group has an open public discussion to arrive at the best decision in a transparent way, which is why we are gathered here today. Okay, so before we jump into the NEP review, I would like to quickly highlight the author of this NEP. Apologies if I mispronounce your names, but we have Andre and Alex on the call today, who is the author of NEP 330. Thanks so much for all your hard work and submitting this NEP. I'm playing the moderator role in facilitating this call. And yes, we have all the work group members present. In the interest of time, I would like to skip introductions. A lot of you already know each other, but hey, feel free to get active in the chat and say hi. And with that said, I would like to move on to the actual NEP conversation. So yes, first we'll have the author present a summary of this NEP and why they believe it's important, and then we'll have the work group discuss their findings and ultimately arrive at a decision. Okay, great. I'd like to invite Andre, one of the authors, to share a summary of this NEP. Andre, the floor is all yours.
Seems like you're muted.
I think Andre is muted. Is he muted?
I couldn't hear him. Or was it on mute?
Okay, yeah, we can hear you.
Right now you can hear me. Yeah, okay. So yeah, this snap should finally fix the problem of smart contracts and smart contracts reproducibility. So as far as you know, there are many factors that could affect the WASM output code, and this snap extension is focusing on write down all these factors and make it possible for the future developers to reproduce the same smart contracts and to get the same WASM code after the compilation. And this would be done by utilizing the smart contract metadata function inside the smart contract. And yeah, you can change to the next slide.
The next slide is actually covered by one of the reviewers. Yes.
So yeah, it's more information on other slides, but yeah, in general, this snap is focusing on finally fixing the problem of WASM reproducibility by utilizing the smart contract metadata and structuring in a specific way that it would be possible to reproduce the code using the Docker image to start the reproducible environment, command build arguments, and the compilation command, and yeah, other stuff that could affect the reproducibility.
Awesome. Yes, Vlad.
Yeah, just maybe to build a bit of a high level view on it, is that when we build the smart contracts from source code, we only publish the WASM code to the chain, and when you have the smart contract deployed and published on chain, to go back to the source code is not possible directly. So the idea was to include the information about the source code, and the other metadata information in the contract itself. So later on, we can go back to the source and view it, but also we want to make sure that the source code actually matches the deployed WASM. So for that, we want to have this metadata that we would use to recompile the same code again, and then that code should produce exactly the same WASM output, and then we can compare the WASM code on chain with WASM code locally, and that would help us to understand that yes, this code actually matches the program that is deployed to the chain. Hopefully that.
Yeah, that's maybe also like highlight why this is important. Like, many smart contracts are both some financial attributes, and it's super important that we trust them. So it's not enough that you trust that it's just a smart contract or there is some team behind it. Often there is an account that deployed the contract, and you need to trust that this is the account, and that there is no some like a phishing attack or things like that. All of this can happen. So if you just see a contract deployed on an account, right, you don't have any verification. And it's really important that we can link a source code to the deployed account contract and be able to verify that the source code is really indeed, the compilation of the source code is indeed the same as what was deployed to the chain.
Exactly. Not to have any black boxes, and every user or every developer in the ecosystem will know exactly what happens within the smart contracts, what to expect from it.
Awesome. Thank you so much.
If you are discussing it like like the next level, I imagine that would be to, if anyone wants to, maybe we can talk about it as a in the follow-ups, but just heads up. It really opens. This update. So this is not a new NEP, right? It's an update to the existing NEP, but it really enables interesting tooling that can be built around it to automate the stuff, automated work.
Awesome. Thank you all for sharing that brief summary on the advantages of this NEP. I believe we have touched on everything regarding this. So yes, Robert, would you like to speak on some of the concerns we saw in the comments?
Sure, absolutely. Let me also add a few things that the NEP provides in general a recommendation, and it's important that this recommendation will be shared between the community, and within when reviewing this NEP initially, yes, we've seen that a few things were missing. The examples weren't clear. So overall, it's a clear improvement as an update to the NEP, besides the added benefits that I discussed at the beginning. So having that specification of a source code and a reproducible build. So overall, the improvements are there. We added the examples, comments, and clarified the structure. Yeah, so that like mainly covers it. I also want to highlight that in many examples you see that to use Docker images. This is the main way how we can really have that reproducible build. Even if you're on the same system, I mean like OS or Linux, you may not, if you don't use a container, you may not have exactly the same build. So yes, we highlight the using the Docker images, but it can be like any container. We put it in the examples, we put it in the recommendations. And yeah, the update in general is small, but very important.
Awesome. Excellent. Thank you so much, Robert, for sharing. So now that we've heard about the benefits and the concerns, let's take a look at each working group member's opinion, which finally brings us to the voting phase. So based on the NEP process, we need a 2/3 majority to move forward with this NEP. We've already had each working group member provide their voting indication on the NEP itself in GitHub, but here is a summary. So yes, we have all 3 workgroup members leaning towards approval of this NEP. But before we formalize the decision, I'd like to ask if any of the workgroup members have any final comments or concerns they'd like to raise. Yes, Vlad.
Yeah, well, from my side, I want to say that Alexei, Oleg, and Vladimir already worked on the integration into Cargo Engineer and tried to basically prove that it all works on various platforms in various environments, and you can actually script it in a very friendly way. But the most importantly was to confirm that the details that we wanted to capture inside the metadata is enough to reproduce the builds. And so far, the findings are that it mostly is the case. But there is always a challenge of missing something out there. For example, we didn't immediately spot that the build directory could be the issue, or the Rust installation path could be the also factor, because some of the strings inside the WASM file point to the files in the file system for one reason or another, for error messages, for example, and stuff like that. So if I remember correctly, it was also amended to the NEP and included the recommendation to basically fix the path to /home/near, and install the Rust tool in there and clone the repo there. And another challenge is factory contracts, when you need to basically include another contract inside your contract. We need to make sure that the first contract is reproducible, have a reproducible binary on its own, and then you can compile the factory contract and include that first contract WASM file inside, and only then it will be fully reproducible. It is a challenge for the tooling, I guess, but I still wanted to mention here for the whole group to make sure that we didn't miss any other corner cases out there. Yeah.
Awesome. Thanks, Vlad. Thank you so much for sharing. And congratulations, Andre and Alex. Okay, so I would like to invite Andre again to talk about some of the next phases in moving this NEP forward. There are also screenshots here on the implementation included. So Andre, would you like to go ahead?
Yeah, as Vlad already said, some people started working on the integration of this NEP into Cargo NER, and NER is the KRS. And the idea is to have several functions built in Cargo NER, like Cargo NER build would automatically connect the reproducible container based and start the specific command and use the specific repository based on the cargo.toml file of the smart contract. And the output would be mounted into the system, and you will be able to access this WASM file and deploy it directly on chain. And in terms of verification, we have like two ideas. The Cargo NER would have the verify function. The original verify function would start the remote compilation process on the SourceCon verification server, and it would pull all the metadata for the smart contract from the chain, build it using this metadata, and then compare it to WASM code that is deployed on chain. And if it matches, the SourceCon sets the mapping for the smart contract that it is verified. And the second option would be to verify locally. So the same flow would happen, but on your local machine without the interaction with the SourceCon smart contract. You would just see like, you can verify it locally without need to set this smart contract mapping. And as you showed the first screenshot, could you please show again here you can see the half of the output of Cargo NER build in the current state. It already uses the Docker container, and you can see that it was compiled on Mac with M2 Pro processor, and here is the hash of the output WASM. And the second screenshot, we used Windows, the same tooling, and we received the same output WASM hash. And the next screenshot, was on Linux, on absolutely other system, and the same WASM was achieved.
Awesome. Thank you so much for that. Okay. All right. So moving on to Q&As, does anyone have any questions they'd like to ask?
May I? So I also think it probably would be cool to see some integration in the blockchain explorers, to show some information about the smart contract. They already have integrations with the smart contract. You can see methods and different stuff. So it would be helpful, especially for investigation and
For that, we actually need to make this Cargo NER the mainstream tool for people to build with, where we already have there is a lot of work going on right now in the space of NER SDK improvements, Cargo NER improvements on the front of making things more discoverable, easier to use. And since NER SDK 4.2, there was like opt-in support for the NEP, for the original version of NEP 360, where only like reference to the code was possible to be included. In the latest version 5.0 release of NER SDK, this was the opt-out, so it was enabled by default, and it's mostly became possible thanks to the Cargo NER integration that just is feeding all that information automatically, so users don't need to bother about it. And yeah, I feel like Andrew can comment on the integration with the explorers. I think SourceScan has something to offer there.
Yeah, actually, we had a lot of talks with guys from NearBlocks, even at the start of SourceCon. So they're just waiting news from us, and as soon as we will finish this integration with Cargo Near, they would be ready to integrate with the contract metadata directly and the SourceScan's smart contract for verification.
All right. Thank you to everyone involved in this NEP and present on the call as well. We're very excited to work together and decentralize the development of NEAR. And yes, just before we close up the meeting, I want to quickly highlight ways you can get involved in the NEAR developer ecosystem. Okay, so if you have an idea in mind, please feel free to submit it using DevHub, or you can find any of the other existing communities to collaborate with. You can also submit your own NEP, and you can view all the NEPs and check out their updates on GitHub. You're also welcome to join our community on Telegram. It's a great way to connect with others and see announcements for meetings like this. You can learn about DevHub on our website and stay up to date on all our social channels. I'll be posting the recording for this meeting and upcoming calls on all of those channels. So yes, thank you to everyone present on the call, and do have a wonderful rest of the day.